Hello everyone, my name is Tian Song. I'm from Huazhong University of Science and Technology in China, Hubei province. Today the topic of my presentation is the cementitious materials early cracking based on the eccentric ring test. 5 parts are included in my presentation. They are research background, introduction about the eccentric ring test, experimental results, theoretical analysis, and conclusion. Let me begin with the research background. The eccentric ring test is developed from the concentric ring test, like the picture shown on the right. The advantages of the concentric ring test are that there is an uniform constraint provided by the inner ring, and the mechanical analysis is relatively simple since the structure is symmetrical. However, it remains some disadvantages in this test, such as the cracking positions are random. To overcome these problems, we proposed the eccentric ring test. The mode consists of 4 parts: the inner ring, the outer ring, a mantle strip, and the base. The eccentric offset between the centers of the inner ring and the outer rings can have a great impact on cracking time as well as the positions of cracks. The experimental procedures of the eccentric ring test is similar to that of the ring test. First, pour the mixture into the mold, then detach the outer rings after the paste hardening. The top surface or the circumferential surface should be sealed according to your research objects. Finally, we can record the cracking, including cracking times and cracking positions. Then I will introduce some experimental results in the eccentric ring test. The morphology of cracks for cement paste and paste added aggregate is different. The only completely through cracks tend to appear on the thin sides for the cement paste, while several fine and pass-through cracks are likely to appear for concrete. The results indicate that aggregate is beneficial to resist cracking. As for cracking times, the left picture is the cracking time in 35% relative humidity, and the right figure is the cracking time in 60% relative humidity. We can, from these two figures, we can see that the cracking time is to increase as the water-cement ratio, aggregate content, and environment humidity increase. For those samples at the aggregates, there may be several cracks. We count the cracking positions by recording the angle beta between the cracks and the symmetrical axis. It is found that those positions where the angle beta reaches a certain range have the highest probability of cracking. And in addition, we record a video about the cracking in the eccentric ring test. The results is shown in this video, and the red arrows indicate the cracking. We call 3 kinds of cracking: crack A, crack B, and crack C. And in the semi-eccentric ring, these cracking positions whose angle beta range from 10 to 30 degree, 80 to 110 degree, 150 to 170 degree. Also, we make a summary of the cracks in the eccentric ring test. And crack A appeared first, then crack B and crack C may appear. Depending on the water cement ratio and aggregate content, those cracks will appear from the thin side to the thick side. Mm, to better understand the cracking phenomena in the eccentric ring test, we can break down the junction linkage on the eccentric ring into two parts: the stress induced by humidity loss and the stress induced by the external forces provided by the inner ring. That analytical method is analogous to the concentric ring test. The theoretical analysis consists of humidity simulation and the mechanical analysis of the eccentric ring. Since the eccentric ring is hard to describe in the rectangle coordinate system, we introduce the bipolar coordinate system to analyze the eccentric ring. And the bipolar coordinate system is useful in the structures with round holes. The coordinates of points can be determined through the angles and distance from the two fixed points. The basic coordinates are eta and cosine. They correspond to the angle relationship and the distance relationship between a specific point to two fixed points. The general expression of the stress function is this equation, and the stress components in the eccentric ring structure are these three equations. What we want to know is the sigma eta, and that is the circumferential stress. This is the main cause for the cracking. After a series of calculation, the particular solution of the circumferential stress in the eccentric ring can be derived. And the result is shown in this equation. And if we apply the radial stress on the inner ring, the magnitude of the stress is 1 MPa. Then we can get such results. Eta equals pi represents the thickness side, and while eta equals 0 represents the thinning side. And we can see that the stress on the thin side is higher than the thick side. Then let's talk about the humidity simulation. According to the European Code, the relationship between humidity diffusion coefficient and the humidity is this equation. And we can use fixed second law to describe the humidity diffusion, like this equation. The boundary condition of the circumferential stress in contact with air can be described as this, and the third equation. And the humidity simulation shown in these two figures, we can see that the humidity contours on the thin side is denser, while the humidity contours on the thick side is sparse. So the humidity gradient in the thin side is bigger. And when some aggregates are added to the sample, the humidity contours become uneven, since the diffusion coefficient of aggregate is lower than the matrix. According to the research from Jason Weiss, the circumferential stress in the ring test induced by the linear humidity gradient has been worked out. The computing method is applied in the eccentric ring test. In the ring test, the stress induced by the linear humidity gradient can be expressed by these two equations. The integrate form of the circumferential stress is this equation. If we use such method in the eccentric ring test, so we can get the circumferential stress induced by the linear humidity gradient shown in this figure. it can be seen that the circumferential stress induced by the linear humidity gradient does not have much difference on the outer surface. Add these results to the add these results and the former results, the stress induced by the radiant stress applied on the inner ring, then we can get the final result, the total circumferential stress. It can be seen that the stress on the thin side is higher than the thick side, and when the circumferential surface is exposed to the air, then the stress on the outer surface is higher than the inner surface. From the eccentric ring test, several conclusions can be drawn. One, the increase of the water-cement ratio, aggregate content, and relative humidity can both prolong the cracking time. And two, a single uncompleted through crack tends to appear on the thin side of the pure cement paste, while several fine cracks are likely to appear on the samples containing aggregates. 3. The positions of the cracks seems to be concentrated on in specific places where their represents angles are 10 to 30 degree, 80 to 110 degree, 150 to 170 degree. 4. The circumferential stress induced by the inner ring is higher on the inner surface and the thin side. 5. The total circumferential stress on the outer surface and the thin side is higher when the outer surface is exposed to the air. 4. The eccentric ring test can quickly affect the cracking time, cracking positions, and other cracking property of cement-based materials. That's all about my presentation. Thanks for listening.